it's not stable.
You are live.
Okay.
Okay. Alright, so what is your job and how is 3D printing used?
Well, I'm retired from Y12, and at Y12 we used 3D printers to build models of things that we were going to build that were extremely large and quite expensive. And it was much easier to build a 32nd or 64th scale model and check for interferences, and we could make changes to the CAD models and then resolve any problems we saw very early in the design process. Now I'm a mentor for the first robotics team at Oak Ridge High School, Team 4265, and our robots use quite an extensive array of 3D manufactured parts.
How did you become interested in 3D printing?
I was in development designing computer-based systems, and I became good at looking at peripherals that computers use, and a 3D printer is just another peripheral. And we started to have interns come in, and I would create design activities that would increase the interns' interest in the field that they were in. And one of the things was being able to build some of the parts that we traditionally machine that took a lot of time, and be able to build those parts instead with a 3D printer. And so we bought several 3D printers, and we started making models, and we started making some of the small parts we use on a printer instead of machining them out of metal.
So what kind of materials have you 3D printed with?
We actually have 4 classes of machines. The first class is in the $1,000 to $10,000 range, and they use PLA plastics, and they melt the plastic and they form the part as a series of layers, and we use those as spacers in the robot, and we can build 40 or 50 spacers in one pass on the 3D printer. And the weakness with the PLA printers is that every time you print a layer, sometimes it doesn't adhere to the layer below it, and the parts have a tendency to delaminate or come apart in between the plastic layers. The next size printer is the $50,000 to $100,000 market, and we have one of those from Stratasys. And what the Stratasys printer does is it uses a mixture of 2 chemicals, and it lays those chemicals down, and then the chemicals harden to form a plastic surface. And with the Stratasys printer, because the previous layer hasn't quite hardened before you lay down the next layers, the layers blend together so that they're imperceptible, and their parts absolutely positively do not delaminate. And so if you look at our robots and you look at the parts that handle power, like the tooth sprockets that we use for our belt drive systems, those sprockets are all made out of the plastic from the 3D Stratus printer. And the third level printer above that is the composite carbon fiber printers, and we have one at the manufacturing demonstration facility at Ornell, and we use that for the parts of the robot that require a lot of strength. And if we made those parts out of structural aluminum, they would break from the repeated stresses. And the carbon fiber the composites have the nice ability to bend but not break and always return to the original shape. And then the top of the line printers at the MDF are the titanium powdered metal printers, and those make extremely complex, expensive shapes, but when they come out, because they're formed with lasers or electrostatic discharge, once we have our electrostatic discharge, they have a tendency for the parts to be very fragile and crack really easy. And so what you have to do to make those parts usable is you have to anneal them. You have to heat them up so the metal is almost softens, and then you basically reform the crystalline structure inside the metal by quenching the parts in a suitable fluid like oil, and then the parts have incredible strength and they work very, very well.
So what is the coolest thing that you've 3D printed?
coolest thing that I've 3D printed. What we can print on the PLA printers, extremely low-end printers, is where you have a circular bearing holder, and inside the circular bearing holder you have 3 sprockets, and inside you have a 4th sprocket. And the inner race has teeth along it, and all the sprockets have teeth on their outer edges. And the 3D printer can build all of them integral as a unit with just a few strands of plastic between them. And when it comes out of the printer, you can start to rotate the sprockets, and you'll break those little strands of plastic that hold them together, and you can actually make gear sets where the gear sets totally work, but the plastic is formed around the gear sets so that it would be impossible to machine in the real world. And the more you use it, the more the little plastic that was used to tie the parts together breaks away, and the smoother the gears work. And so after you use it for about 5 minutes, it becomes a really good working gear set. And it's a shape that would be almost impossible to machine on the metal.
That's pretty cool, actually. So what's your favorite part about 3D printing?
When we're building a robot, we build a robot out of either 3D printed parts or structural aluminum. 62, I think, which is basically high tensile aircraft quality aluminum. And we model it all in SolidWorks, and to save weight, we etch shapes into the aluminum to cut away the aluminum where we do not need it. So the aluminum parts we have to send out to a numerically controlled machining center, and it takes about 3 or 4 days to a week to get the parts back. Whereas the 3D printed parts, we can start the printer printing in the evening, and overnight it can run for 14 or 15 hours. And the next morning when we come in, we have all the parts. And the 3D printers have a bed. And a numerically controlled machining tool, you can only put in one part, machine it, and then you have to take it out, put in the next part. With the 3D printers, we can arrange an array of spacers that are 1 inch in diameter, and we can put an array of 40 or 60 of them on the bed of the 3D printer. And as the 3D printer head passes across the bed, it simultaneously prints all 40 to 60 parts. And so we will start a print job for all the parts that we need in the robot in terms of spacers, and we will build 60 spacers at a time in the printer, and it will take it 12 hours, and basically we have all the parts we need.
So what do you think is the greatest future potential for 3D printing?
The greatest potential for 3D printing is in the world of medical devices, where we're designing artificial knees, artificial joints. And what can happen in the world of 3D printing is you can build a spreadsheet that's a parameter that lists all the various dimensions that goes into designing a knee for a given human body. And then you can go into SolidWorks, and SolidWorks can pull all the information it needs to design a knee from the spreadsheet. And so at that point, the 3D printer can tailor and build a unique knee for each unique person, depending on the parameters of that person's body. And so the real strength of 3D printing is going to be in fields where you're designing complex things, and because the complex thing is going to be used by a person, there's no additional cost for tailoring that thing for that person, such as like an artificial knee.
Thank you for your time.
And I enjoyed this.